data center operator can order the newest GPU rack and still wait years to switch it on. The missing part may be a transformer, circuit breaker, turbine, or completed interconnection study. In a March 2026 webinar, the U.S. Department of Energy said large transformers for substations and generators had lead times of roughly 3 to 4 years. The digital product moves on quarters. The electrical machine moves on industrial time. Electricity does not jump from a power plant into a server. It passes through generation, high-voltage transmission, substations, transformers, switchgear, and campus distribution. Each link has ratings, protection systems, permits, and commissioning tests. A large AI campus also needs backup power and redundant paths. Buying processors before securing these links is like buying aircraft before building a runway. The bottleneck is the slowest qualified component in the chain. DOE said demand for distribution transformers increased 41% from 2019, while order lead times expanded from 3 to 6 months in 2019 to 1 or 2 years or longer in 2024. Large power transformers can take even longer. Data centers are not the only cause. Utilities are replacing aging equipment, electrification adds load, and factories need service. AI enters a supply chain that was already under pressure. Transformers are not perfectly standardized. DOE has identified more than 80,000 distribution transformer varieties across U.S. utilities. Different voltage, cooling, connection, protection, and accessory specifications reduce the factory's ability to repeat one design at scale. Large units are frequently custom engineered and difficult to transport. More factories help, but common specifications, trained labor, grain-oriented electrical steel, test capacity, and logistics must expand together. A supplier backlog can indicate strong demand, but it is not the same as revenue. Orders may include cancellation rights, delivery windows, escalators, and customer deposits. Manufacturers must buy materials, expand plants, hire technicians, and finance work in progress before shipment. Buyers face their own choice: reserve equipment early and risk an idle asset, or wait and risk losing a power date. Industrial scarcity creates value and working capital pressure at the same time. FERC warned in June 2026 that speculative large load requests can clog connection queues, divert engineering work, and distort forecasts. A data center developer may shop the same prospective project across utilities, making demand look more certain than it is. FERC directed regional grid operators to justify or reform their large load rules. The purpose is both speed and discipline. Projects should demonstrate readiness before the grid builds expensive infrastructure around them. The opportunity spans transformer makers, switchgear companies, turbine suppliers, cable producers, engineering firms, and testing specialists. Yet one product line does not solve every problem. A distribution transformer serves a different role from a large generator step-up unit. Gas turbines need fuel and permits. Switchgear must match fault levels and standards. Track exact equipment classes, factory expansions, qualification dates, and delivered units, rather than treating the entire electrical industry as one backlog. Standardized transformer specifications can increase repeat production. Flexible load can let a campus connect before every planned upgrade is finished. Reusing industrial sites may provide substations and transmission access. On-site generation can help, but creates fuel, emissions, and reliability questions. None is a universal shortcut. The best projects coordinate land, power, equipment, network, and construction before promising an operating date. Ask which transformer, which voltage, and which lead time. Is the item ordered in production, shipped, or commissioned? Is the power firm or dependent on a future line? Does the backlog carry deposits and cancellation protection? Is the interconnection request unique or duplicated elsewhere? A press release with megawatts but no equipment and readiness milestones describes ambition, not an energized campus. The physical AI race is paced by equipment that rarely appears in a model benchmark. Transformers, turbines, breakers, cables, technicians, and grid studies decide when silicon becomes useful compute. The shortage is not simply a reason to buy any supplier. It is a map of mismatched clocks. Follow the machine, the order, the factory slot, the connection agreement, and the commissioning date. The rack only earns money after the whole chain is live.